so that's good. What?
For the record, I want to wait for the record, so
Oh, sure.
7 seconds.
So specific.
And I will show you signs with 10 minutes and 5 minutes remaining.
Okay.
So, hello everyone again. Let me introduce you, Vincent Batts, senior developer from Relay, and he will be talking about golang.
Yay! So I'm Vincent Batts. I am with Red Hat. So even though it said on the track that containers, this is largely a language talk about Golang, the language. The good, the bad, the ugly. I know looking around the room, there's several of you that I have worked directly with in writing Golang. How many people have actually written Golang at all? Okay, surprisingly small amount of hands. How many people have read about Golang and feel like they formulated some kind of an opinion one way or the other? Significantly more around the room. So I actually came to Red Hat having played a bit with Golang even in its premature days and figured out some of the use cases that do and don't apply to most people. Since then, there's been things like Docker that some folks have heard about that have drastically brought the language into a everyday conversation. So, okay, so this is basically me. I'm actually on development. I'm on the Openshift team, but for at least the last year, I'm working pretty exclusively on Docker upstream. So if you have Openshift questions, I'll try and help you as best I can or get you the people that would know. If you have Docker questions, I'd love to talk to you. So Golang, what is it? It's got a gopher. It's got a really cute mascot. A lot of people really like it. Rene French, he made it, and it's everywhere. The gopher does all kinds of things. It's cute. And as a language itself, it is strongly typed. It is very C-esque. It is a compiled language. The quorum, or the core team that actually started the language, are a lot of old names like Rob Pike and Ken Thompson from like the guys that wrote the book on Unix and they wrote the book on various types of compilers, plain non-compilers. So they were very opinionated in the way they did a lot of things. But they also came at it from a stylistic approach that it should not be an awful language to write. It should not be an awful language to read. It should be as quick in writing it as compiling it and using it so that you can iterate quickly. This was the use case they optimized to. So the good, and I'll go ahead and prefix most of these, the good, the bad, the ugly. As I'm writing it, I'm knowing that people complain about these things, but I myself, I feel two ways about it. Yeah, like in this use case, this thing might be good, it might be bad, it might be ugly, but in another use case, that's perfectly reasonable or in fact a good thing. So the good thing, you're hearing all kinds of good things about Golang right now. I mean, like it sounds like everybody's in a heyday of writing it and compiling and shipping static binaries all over the place, and everybody's unicorns and rainbows. Some of the nice things that I like about Golang is the imports now are fully qualified. So how many folks have written languages like Ruby? Okay, so a quarter of the room. One of the biggest complaints that you hear about in Ruby is that you'll see something require some name. The thing that you actually require has absolutely nothing to do with what you gem install. You actually have to go out and search for what is the actual gem name that I need to install, and what am I actually requiring, and then what are the actual class names that I have to talk to. That is an incredible frustration. I much more prefer the Python way of life, where you have an import and everything's scoped to that import. You can know what you're working with. This takes it a step further, and actually the import is fully qualified so that when you go to look at somebody else's code, you don't just have to say, where did this code come from? It's in the import, so that when you actually go to fetch it, the code can be parsed itself and know where to fetch all the various libraries from. So even if you fork somebody and have a fork of the exact same library, the import path has changed. So you don't have to deal with, I'm dealing with this library, but that person's fork, it's expressed right here. Fast compile times. So I say this is fast compile times, and it is very fast. Many projects that you have, they compile in like less than a second, just pretty fast. But most people will even argue it might be fast, but it's also that other compilers like C++ are just dreadfully slow and do stupid things like including the same file over and over and thousands of times, such that it takes a long time for it to actually compile. So in this example, here's a full hello world. I'm from the southern states, so howdy y'all. And I'm going to run this for you, and watch quickly. It will actually compile this code and evaluate it. Done. So in this, it's almost like you feel like an interpreted language where you just told it to do something and saw the return back on it. But behind the scenes, it actually fully compiled that binary and executed it. And I mean, just to show you that that's not set up. So it's pretty quick in compile time. So it lets you have something that you can ship, but iterate pretty quickly. Another nice thing, deferrals. Who is mildly familiar with what a defer might be? So a few folks. Defer is often that thing that you have to deal with in languages like C that you just wish that you could say, at some point, whether I return from an error or whatever, make sure that you close this file handle. Make sure that you clean up this file. Make sure that you OS remove a whole directory. I might create this file. I need it removed when I'm done. You can defer that, and then after the function, whatever it is, after the function is returned, it pops those functions off the stack, and it says, he also wanted to remove the file. It also wanted to remove the directory. It also needed to close the file handles, so that regardless where in the function you might have returned an error, you can make sure that you're not leaving file handles left open. What's your comment, Alex?
I wrote it. There's a C attribute cleanup that does the same thing.
Oh, nice.
And it's all macros and glib that can use it very nice.
Magic and glib. Sure. Yeah, so it is a very useful idiom, and so it's first class here. Alex is saying that there's such a critter that exists for glib and macros and so forth, but it's a very nice idiom where you don't have to see in every possible place that an error could occur that you also are closing files and also returning and have your laundry list of items. You just say, at some point after you're done, be sure to close and return. It is a garbage collected language. So this is one that, I mean, especially most people coming from interpreted language or whatever very convenient languages like Ruby and Python, they just are like, okay. But coming from the C world, there's contention about this. I put it in the good category because, by and large, it is pretty convenient garbage collection. There's some extent that you actually have to remember whether items are going to still be referenced or how long something is going to be in scope. Most often, you never have to deal with the woes of when garbage collection is actually happening. It just happens at some point. Be smart about it when you're writing your code. and be smart about it when you're using Go routines, but that's not just for garbage collection, that's just for clean code. And I'll get into Go routines in just a minute. So exports. They're often when people come and look at the code, they say, where are you actually declaring what is public and where is private and what's, how is that handled? Or they write some code and they go to use it in a library and say that it's not allowing me to access it. The exports are pretty simple. There's no declaration. It's rather implicit, but it has to do with capitalization. So in this scenario, or in this example here, I have a struct of foo. Foo is capitalized. So if you were using my library, you would see foo. Foo has a couple of fields. You would see bar. You would not see baz. So it's pretty straightforward. I have a biff struct, which would not even be accessible outside. So even though those two, it has a couple of harf and buzz attributes to it, it's not even important because biff is only usable inside the context of this library or this package. So the exporting for private and public is simple. I forgot to say this. If you have questions at any point, just raise your hand. Like, please interrupt me. Any questions? Okay. So concurrency. This example I did not write. I'll get full attribution to Samir in the advanced concurrency talk. He works for Google, but concurrency, Golang in itself is natively concurrent. So it will do threading if it's only on one core, and if it has multiple cores, it'll span the multiple cores and make sure that its runtime is balanced across that. It's built in. It's good to learn about it, but it is so easy to use that you can start with it straight away and not have to deal with asynchronous threadings and callbacks and all this kind of stuff. So just as an example here, and I'll walk through this code briefly, you've got a ball that has hits, like whether or not it has been hit. Every time it's hit, it's incremented. We're going to start a table, bless you. We're going to start a table which is just a means by which to move the ball back and forth. So here you see we have a table. I'm creating a variable called a table that is a channel, and the channel, which is in Go world like a FIFO, like it's a pipe that you can move data back and forth on. Well, you can move data through. So I have a table that is just the means by which for a ball to move. Make is kind of like an alloc. A malloc, you can create, it creates a pointer that's allocated for the type that you've just specified there. There's a couple of different ways of instantiation. Nowadays, you'll see a lot of people do something similar to, foo equal, bar with curly brackets. This is also an instantiation, but for various types, it's more efficient to malloc them up front with make. So for channels, you have to run make for the type of channel that it is, so it can set that up in the runtime. So I'm making a channel. You see Go player. We have one player that does ping and the other player that does pong, and we give them the table that the player is going to be playing on. What is actually happening here is that player is a function. Go says that it starts a Go routine. Like in the background, you players are going to be playing, and if I started it right here and did not have this logic at all, the function would the whole program would end. Nobody's doing anything. The players were ready to play, but the function returned. But what we do next is we actually are going to throw a ball onto the table, and both of the players are sitting here ready to play. I'm going to throw a ball on the table. Yeah, so this operator is how you interact with a channel. So channels are part of concurrent logic theory so that you can actually have the means by which to push data onto it or pop data back off the other side. This is an unbuffered channel, so it would be a blocking operation to push if there was already something on the channel, and it wouldn't be able to push something on until something was popped off the other side. So here I'm pushing a ball onto the table. We're just going to wait for a minute while the players are playing in the background, and then we're going to take the ball off the table, and it's all done. This is just the incrementer for how the players are actually playing. Ping pong, ping pong, ping pong, ping pong, ping pong, ping pong, ping pong. Program and exits. So so if you actually looked at it threading-wise, I started 2 threads that are just players ready to play. I threw a ball on the table. I take the ball off the table. That's how much they can do in a second with some millisecond sleeps. So concurrency, if I wanted to do this in some other languages without a bunch of callbacks, without a bunch of asynchronous type programming, it might be a very lengthy program, and who knows, like if you're just going to get it in one slide here. But the concurrency is actually, it might be new looking, but it's pretty straightforward in a lot of ways. Questions? This is crazy stuff, I realize, but okay. So other good stuff, I mean, you could go on and on and on about the language. I mean, there's various bits that, again, you could say are good or not good. I want to point out, though, that it has a surprisingly easy learning curve. And even if you're just looking for a pet project or to see if it suits any of your use cases, obviously get familiar with the language first. But especially in the last year with all the Docker business of everybody needing or wanting to do something with Docker or helping in all different teams, even within Red Hat, I've been able to sit down with somebody who's only pretty much ever written in Python, and they're writing fine and good Golang within a couple of days. Only ever written in C, they're writing fine and good in Golang in a couple of days. Only ever written in Java, just a couple of days. Some of the concepts like a concurrency, you don't need that all the time. So don't worry about mastering the universe right up front, but to be able to start writing code right away, it's a surprisingly short learning curve. The same couldn't be said of some languages like Rust, where you actually have to get involved in learning it, or Haskell or OCaml. It's an involved learning process. Go is actually a pretty quick learning process. Go Get. A lot of people have commentaries about Go Get. If you yum install Golang or pull it from wherever you get packages from, one of the things is that the tool that most, like the compiler and the linker and all this, is wrapped up in a Go tool. It has subcommands: go install, go build, go test. Go Get is most of how you'll see some projects say, here's a new hot command, go get github.com/vbat/whatever. What happens behind the scene is that it will actually check out whether it's git, hg, bazaar. It will actually go fetch the URL that it's been passed. It will pull it down. It will see if there's other external imports. It will fetch all those into a local user Go path. It will build them, and it will put the binary in your bin directory, wherever you've designated that to be. And so you can just go get something, and then it's just in your path ready to go. It's very usable. So this is already like a deployment process, but this is also, there's ways around it, but largely everything's built off of master. So everything's always the latest and greatest. You just go get it, and you can say update, and it just works. Questions about that? Security around Go Get? Signed repos. It clones most of GitHub and Launchpad and code.google.com. There's a few of those default ones that it makes assumptions about. Those are all cloned over HTTPS. And so it uses a system certs to make CA certs to validate that those are signed domains that they trust. You can pass it other repos, even over HTTP, and there's not a model for that. So it's more trusting that you know the code that's written in there, and if you, like anything, if you're just pulling in some willy-nilly library, you should be aware of what they're also using. But most of it's just an HTTPS trusted transaction. So lastly, in the good category is cross compiles. So the Go compiler itself from the Go team has a handful of natively supported architectures. Windows 64 32-bit, Darwin 64 32-bit. Yes? not. So that's why I said largely it's master. There are some projects, so the question to repeat was, can you specify a hash for it to fetch in the go get? So there are some projects, like one is called go.pkg.n. Niemeyer from Canonical wrote it. Anyhow, his project allows you to actually reference version markers. So if your project has a full V1, V2 tag on GitHub, that you can actually point to those and he'll translate so that what actually gets cloned down is that tag on GitHub. Otherwise, there are outside toolings for, most popular one is called godeps, where you can actually make a file that you cannot go get it at that point. You'd actually have to check out the source code, go into the directory, run a command, and that command would fetch all the different repositories at a particular revision. So to go get is often just assume you're getting master, but otherwise projects that need specific versions, specific branches will use outside tooling like godeps or their own custom scripts to fetch. Yes? Mm. Mm-hmm. Okay, a question back. So then inside of your code that uses those libraries, do you then use a fully qualified vendor path within your project? Yeah. Okay. So his addition was that for projects that he uses, libraries that he uses in his project that are the head or master is moving too fast, he just what they call vendoring, where he clones or forks that whole tree into his project on GitHub, but then his imports that would use that library are now GitHub/his account/his project/vendor/GitHub/that name/that other project. So it's still, he's forked it, but it's fully qualified to his path, not their master. And periodically, you may or may not pull in from their master as needed. So this is one of the other idioms, third party or vendoring. All right, so cross compiles, real quickly. The Go compiler itself supports Windows, Darwin, BSD, Linux, and then a further ARM, 32 or 64-bit on a variety of those platforms. The Fedora package has all these available. If you just yum install Fedora yum install Golang on Fedora, you'll get whatever your platform is, Linux 64. But you could just as well, also there's packages for like Windows 64-bit. So if you were on your Raspberry Pi, running Fedora on your Raspberry Pi, 32-bit ARM, you could actually install the package so that you could produce with the hello world. You could produce a binary that is a Windows 64-bit binary with just installing one extra package. The Go compiler has it in. It's not a big bootstrapping process. If you're compiling it from source, it's really not that much more to do that. So the Go compiler itself has a lot of cross-compile features in it. If you're using GCC Go, it's just going to be whatever the platform or architecture that GCC was compiled on. But the cross-compiles are pretty easy on the Go compiler. All right. The bad. So again, a lot of these bad features people complain about, and other people actually praise them. But regardless, they often are affecting how you do your job. So you wanted to point out that the GCC that's in Fedora can also do cross compiles, but are the packaged artifacts that it would link to or whatever also built for those other platforms like Windows and so forth?
Yes.
Oh, good. Good. This is something that I probably don't play enough with. So yeah, so GCC Go also has plenty of traction, and there's a lot to be said about that. But I fully hope if you're involved in wanting to play with Go or GCC, all these things have lots of conversations going on. So feel free to get involved with that. All right, so the bad, packaging. Hey Dan, how do you feel about Golang's packaging? Dan Walsh, ladies and gentlemen. So the packages, if it has a lot of dependency, when you're dealing with packaging guidelines, especially like the Fedora packaging guidelines, which have absolute principles why they're there, some of the idioms that are in Golang fly in the face of these guidelines, and they're not really compatible in certain ways. Most like the libraries are all source only, because so as far as packaging, they're just build requires. So if you're going to ship Docker, you need a bunch of build requires, and then the Docker RPM that comes out of it has really no dependencies. It might have a few, but they're not dealt with what it's linked to specifically. So packaging is as some folks would say, it's a non-issue because it doesn't happen. So it's only distributions that are trying to deal with packaging and having the headache. Lack of generics. Does anybody have an opinion about this? I don't really have an opinion strongly one way or the other. Some people really like generics, and there's reasons for wanting generics. In Go 1.4, there's now a feature where you can go generate. So if you have something like a set or some piece of logic that's going to need similar functions regardless of whether you're dealing with strings or arrays or ints, strings or ints or whatever, you can just generate the code that would do that rather than having to deal with an ambiguous type. But this generics is probably one of the single most debated features and argued about features that happens on the Go development lists, and the Go core team is just like, we're not going to do generics. Debugging. Has anybody had experience with debugging Golang? So debugging is not really there. It's one of those things where you're iterating fast enough that printfs are pretty good, and especially printfs like this crazy one, this %v. You should make friends with %v, because then it doesn't exist in other printfs, but in Golang, this will actually do a verbose inspection of the object that you're looking at. So if you %v it, you can actually see the type of struct that it is, the name of the field, and the value of the field, and it'll stringify them as best as possible. It's probably the most useful debugging feature. Yes?
How in the world do printfs help into concurrency?
Yeah, you have to get creative sometimes, because even GDB, you can actually use GDB, but as soon as you start having any kind of threading or concurrent logic, GDB is just like, I don't,
There is a special package file from GDB which I know updating because we have today that you never run, for example, coroutines or coroutines, number of coroutines, and some specific GDB commands.
is this outside the one that they provide?
It's inside Golang, but the script is Golang doesn't work with the box.
Are you pushing this up to the Golang team? Or
Working on it now, so yes.
please get back in touch with me. That's great. So he says that he's updating. So there is a provided in the Golang source tree. There is a Python script that extends GDB so that you can actually inspect objects and see more information. So GDB is not completely useless, but as soon as you start having any kind of threading, it's largely useless. He says that he's updating this Python script so that it actually will work with Go routines better. That's amazing. Various ELF tools are not useful. There's objects, and you can actually object dump it, but if you're intimately familiar with C and C++ programming, it's different. The compiler compiles them differently. The tools don't work the same. So debugging often comes back to printfs. There it goes.
I would like to say that the Go developers believe that the debugger will solve everything, and there should be debugger solve the else. But the problem is that Golang produces poor bar information for debugging and don't overlook bars, so I think it cannot work as well because in the future. So
So there's the comment was that there is a project called Delve, which is written in Go to support Go debugging, but while it actually does it often does a better job of debugging than GDB, it also will probably end up running up against the same kind of problems and won't solve the problem. And it's actually kind of ironic because one of the reasons they ended up naming Go is because they thought it would be really funny to have something, a debugger called Oogle, so that they could go Oogle something, but there's not actually a really good debugger, so forth. Yes, and I mean contributions are welcome. The core teams, honestly, more often than not, because it solves the use case that they are looking for, and perhaps many people that are writing it in their use case parameters are smart enough to not need a debugger. It's not important enough to them, and like packaging and versioning, the core team is kind of like, we'll leave it up to the community to figure that out. So some things have incrementally improved, even like as of Go 1.3.3 or maybe Go 1.4.4, they finally added in the note section for the GNU build ID, so that you can actually have build ID on the segments of the compiled language, whereas it didn't have that for a long time, so you couldn't use the ELF utilities to inspect for the build ID of it. So, but that's been added since then. So there's incremental additions to things, but for like debugging, it's probably more than an invitation to get involved. There was a question over here.
No, that's what I wanted to address because I think they are working some packages for the project.
Yeah, they've said that they want to address it, and there might be more coming, like in Go 1.5. But I know some of their efforts are actually on. The compiler has been written in C, and starting with Go 1.4 and towards Go 1.5, they're slowly actually bootstrapping to rewrite the compiler and linker in Golang itself. But they've said that having a proper debugger is high on their list, but after other things that they're working on. Concurrency and GCC. So if you're, there's another question. I'm sorry. 10 minutes. Mm.
If you change your methods of development, instead of thinking of, I would borrow more from Python and decide that you have many unit tests and many methods of checking your code around those sections, you actually are able to debug faster. Sometimes I've debugged systems with 800,000 code routines, and I can see exactly what's happening by being able to isolate those functions.
Mm-hmm. Yeah, so unit testing, I didn't even get much into unit testing, but GoTest is built right in. There's a stdlib library for testing. Most libraries are almost test-driven development as it goes along, because as you're implementing something, you want to be able to have a way to test main executables as well as libraries. Okay, so I'm going to probably speed up a good bit. So concurrency and GCC, garbage collection, if you're doing much with C-type linking of functions like set and s, they just don't work quite the same, because there's so much care taken within Golang's garbage collection and concurrency with the runtime that when you need to do something like set ns for the current host PID, you might just be in one of your threads or routines. It might not apply to the whole PID. So some functions like set ns and fork exec are just, fork exec's ns. Fork exec are just a pain in the butt. Can I hold questions towards the end so I could just skip through? So hold on to that. I know I said interrupt me, but. So fork exec are actually not separate but together. You fork exec something, you don't actually fork and then get your PID ready and then exec. So for some container technologies, this is very difficult. It's a surprising use case for folks to be so persistent about writing certain technologies in Golang, but so it goes. So ugly, maybe it's just new. I just love this GIF, I don't know why. But still, so build tags. There's no if-defs in Golang. It's not like you can get to a particular segment of code and say, if-def you're on this platform or this thing is defined, act like this, otherwise this other thing, and just have a little chunk in the middle of your logic. There are there are build tags so that you could actually have a function that's almost like an extern, that some function will be defined, and then you'll have a separate source file for being compiled on Windows and a separate one for Linux or POSIX. So build tags, some people, again, think it cleans up the codes rather than having cluttered if-defs throughout one line, one continuous stream. But others just think it's kind of ugly because now your logic might be split out upon a couple of files. I kind of like the underscore. Underscore is a bit bucket. So if you ever, the code will not compile if you've created a variable that you don't use. So if you need to assign a variable and you're not going to use it, you assign it to underscore. It's like a bit bucket. But otherwise, you can't just create a variable that you're not using. The code just won't compile. Channels. Just like earlier, what is the operator? Channels are a new type of operator that you're pushing variables onto the channel and you're popping the variable off the channel. So maybe it's ugly, maybe it's just a new way of thinking about a new type of operator to interact with. So it's pushing something on, starting a go routine, and then waiting for right here for it to pop off. So it's might be ugly, might just be a new way of looking at it. IOTAs, there are no enums, there are IOTAs. So this is an overly simple IOTA, but probably the most common that you'll deal with. You'll also see some pretty neat interactions with IOTAs that it's just an increment. Every one is just an increment and it starts on 0. You could actually start IOTA bit shifted 3 positions, and so every next const in this scenario, every next const would be bit shifted by 3 positions, and it's almost like a way by which of enumerating variables on a given path. Most people are just going to say 0, 1, 2, 3, 4. For ranges, so some of the primitives that you deal with in Golang are like an iteration. People have take claim with because they have kind of conditional returns. So here I want to say for the index and the name in this list of names, or maybe I just want to take just the index of this list of names, or maybe I just want to take the name. I actually don't care what index it is. So the code is, they're all pretty equivalent. The last one, I don't have an index, but dealing with 4 ranges is kind of interesting. Some people interact with them differently. You can do the same 4 range over like a map, a hash map of some kind, and it instead of giving you the index, it now gives you the key and the value, whatever that is. Another one that people come from, especially like C++, and they say, well, where's my iterators? How do I actually create like an iterator over something so I can just keep asking for the next one? You can actually use channels that way. So in this situation, I've actually got a function called read'em and weep that just returns a channel that will pop off the type of item that I'm looking for. So I can just say, for range in this channel, like as long as this channel is giving me things to read, just keep iterating over those. So you could actually start a go routine to populate the channel, and once that list is done, the go routine gets garbage collected, and you can have something that feels like an iterator. Maybe it's ugly, maybe it's just new. Here's that same logic on the back end. The read'em and weep, it hands the channel back. It just starts a go routine and returns the channel that it's talking to. So that go routine will just sit there and wait to push on the next item until you read it off. And once it's done, it closes it and cleans it up. All right. So conclusions. Like so many programming languages, honestly, learn it enough to like it and dislike it. If you've formulated an opinion on Golang and you've never touched it, go play with it enough to say, okay, maybe it doesn't do that well, maybe it does something else better. But it's not always just going to be like a good language for absolutely everything. There's certain use cases that it will apply to and some that it won't. Thankfully, Go has a lot of good documentation. The documentation is easy to read. It might be backwards if you are looking at it for the first time, but There's plenty of a community out there. What is the forums, and when you search for like Golang iterator, you'll find something on the different forum websites or even the Golang Go Nuts mailing list. So there's a good community out there with information on it. Okay, so questions. There was one in the back here, if you still remember your question. Yeah. There's been a churn on the garbage collection, and it's drastically improved. I have not actually gotten involved to figure out all the different principles used in it, but a lot of people were perfectly okay with the garbage collector for a long time, and then around Go 1.1 or Go 1.2, they essentially overhauled it, and it's now become almost negligible. You can almost, you might not even notice it for most applications when collection is actually happening. Is there a global stop? I don't think so. Honestly, I've never even noticed it if it has been there. So, yeah. Okay, question.
I do have to ask how to deal with dynamic libraries.
How do you link against dynamic libraries, or?
Well, it asks dynamic libraries, so what can you do if you want to use some dynamic libraries?
So there is a library called CGO. You can import from C and straight start using includes. So in any given directory, when Go goes to compile it, if it's a .go file, it will know how to compile that. You can also straight up use C or straight up use assembly. But there's even ways to do inline C and link against like lib device mapper and whatnot. So
dynamic library problem, has it been someone solved or not? If I
you cannot
simple Go program, it is static binary.
Sure.
1 megabyte.
You cannot write Go dynamic libraries.
But can I use dynamic libraries from Go?
Yes.
Yes. Okay.
Yeah. And GCC Go binaries are smaller, but it links against libgo. Okay, I'm out of time. But feel free to hit me up afterwards. Thank you all. Here's my Twitter handle.
What kind of magic lets you run the code in the presentation?
A presentation is written in Golang. That's what.
Okay.
Yeah, it's actually they wrote a tool within the Golang Go tools repo, and it's just a bunch of fancy JavaScript that compiles it on the back end. So you can just edit it in slide and compile it on the fly. It's crazy, but it makes these examples really easy.
Yeah. Very nice. Hey. Hi. Vincent, do you have PDF for your slides?
I put my slides on there, but